Okay, we are on page 276. We start the page with what's called an error analysis. Lisa evaluated the expressions 2x and x squared for x equals 2, and she found that both expressions were equal to 4. Lisa concluded that 2x and x squared are equivalent expressions. How could you show Lisa that she is incorrect? It's pretty interesting what happened here. And so I'm going to go ahead and get a whiteboard out. And here's what she did. She took two expressions, 2x and x squared, and she straightened them separately. And she said, I'm going to test these to see if they're equal to each other. She put an equal sign maybe and a question mark. She doesn't know if they're equal to each other, but she's going to test it. And she decided to test it for x equals 2. So over here I'm going to write x needs to be equal to 2. So I'm going to take out this x. I'm going to rewrite this one as 2 right next to 2. I'm going to take out this x. I'm going to make this one 2 squared. Well, what is 2 right next to 2? It means 2 times 2. That's 4. And what is 2 squared? Well, that means 2 times 2. That is 4. So the answer is yes, they're equivalent. And so that's her conclusion. Yes, they're equivalent. The question is telling us, A, it's an error. It's telling us an error. And B, how could we show that she's incorrect? Well, we're not going to show that it's incorrect by disproving her math. She didn't do any math wrong. All this is true. The interesting thing about this is that she only tested with one number. You should test with 2. For example, if I rewrite the expression 2x and x squared, and I'm going to test it for 3 or 4 or 5. Well, you're going to look at this for a second and think they're equal, but watch how they're not. If I take out x and replace it with 3, this one's going to be 2 times 3. And if I take out x and replace it with 3, this is going to be 3 squared. And are those equal? Some kids are going to say yes, but they're not. 2 right next to 3 means 2 times 3. That's 6. And 3 to the second power doesn't mean 3 times 2. It means 3 times itself. It's 9. Is 9 equal to 6? No, they're not equal. And that's going to be the case with all answers except 2. That's what's really interesting about this, is that she picked a test number that made it look like it's true, but it's actually not true. I'm going to change out x for 4. I just tested it for 3 and they weren't equal. I'm going to test it for 4 real quick. And once again, you might look at those and think, yeah, they're equal. They're not, because 2 times 4 is 8, and 4 to the second power means 4 times itself. That means 16. They're not equal. So how could you show, here's the question, how could you show that Lisa, that she is incorrect? You could replace x with other numbers besides 2, and you'll see that the values are not equal. I'm going to say that the expressions are not equivalent. That both things are true. And then I'm going to add a second sentence. You need to always test more than one number. Now on the first page that we did this, we tested with 3 and 5, I think it was. And they sure seem to be equivalent. On this one, when we tested with more than one number, they sure didn't seem to be equivalent. Okay, good job. Let's move on. Now we're on modeling, and this is going to be a little tricky, but hey, you know how it goes. I'll do my best to help you. Read with me. It says modeling equivalent expressions. You can also use models to determine if two expressions are equivalent. Algebra tiles are one way to model. Here's what you got to know about algebra tiles. They use big ones and little ones. And the little ones are worth 1, and the big ones, we don't know how much they're worth, so they're worth an x. So a little one here, that's a 1. If I have 2 of them, that's a 2. If I have 3 of them, that's a 3. And the big ones are, I'm going to put a plus sign, and because these are positive numbers. If you're wondering why there's plus signs there, it's because we're dealing with positive numbers. When you get to 7th grade, they'll have some negatives too. Either way, these are all each 1. This one right here is an x. Okay, so pay attention to our key. Our key up here, it's kind of like a key on a map. Pay attention to our key up here. Our key up here is that the little ones are worth 1 and the big ones are x. Okay, so let's go ahead and move on to question A. It says, determine if the expression 3 parentheses x plus 2 is equivalent to 3x plus 6. Well, how can we do that? It says, model each expression using algebra tiles. I want to show you, the one on the right, actually, look at this one right here. This one is this, and that makes a lot of sense because look, it says 3x, and we just pointed out that the long ones are an x, so you've got 1, 2, 3. 3x, 3x's. And that says plus 6, you've got 1, 2, 3, 4, 5, 6. I hope it makes a little bit of sense to you that 3x plus 6 is this right here, 3x plus 6. There's your 3x's, and there's your 6 singles. That's easy. This other one's a little harder to understand because it says x plus 2, parentheses 3. Well, this should make sense too, though, because think about it. This one right here, x plus 2, just this part of the expression, x plus 2, this would look like this. There's your x, and there's your 1, and there's your other one. So that's x plus 2. Do you see how that's x plus 2? And then this right here means 3 of them. So if this right here is x plus 2, and there's another one here, and there's another one here, then 3 means you have 3 x plus 2's. Now the interesting thing about that is that if I reorder these, they're all the same. And here's how we can prove it on B. B says the model for 3x plus 2 has blank x tiles. That's an x, that's an x, and that's an x. So it has 3 x tiles. And it has how many 1 tiles? 1, 2, 3, 4, 5, 6. The model for 3x plus 6, that's this model right here, has blank x tiles. 1, 2, 3. And blank 1 tiles. 1, 2, 3, 4, 5, 6. Is the expression 3, I'm on C now, is the expression 3x plus 2 equivalent to 3x plus 6 and explain? The answer is yes, because they each have 3 x tiles and 6, and they're just called plus 1 tiles. I don't know a better way to write those. You could call them 6 1 tiles, but I'm going to call them plus 1 tiles. They each have 3 x tiles and 6 plus 1 tiles. That's it. They have the same amount. And if you can't see that, what I would hope, I don't know, it's tough to see, I guess. Maybe it's not tough to see. If you can't see that, just think about this. Think about taking this one and replacing them right here. Taking these and putting them here. Taking these and putting them here. And now this picture is identical to this picture. They're just reorganized, and that's the thing here. They don't look equal when you write them like this. If I wrote this as, are these two things equal to each other? They don't look equal, but they are, and we could prove that. We could prove that differently. We could prove that by testing, just like we did on the previous pages. We could prove it by testing. We could put a number in here. Let's put in x equals 4. Let's put in 4 right here. What's 4 plus 2? That's 6 times 3 is 18. Put in 4 right here. 3 times 4 is 12. Plus 6 is 18. Now that doesn't prove they're equal, but it suggests they are. All right, let's move on. We're going to do algebra tiles for the reflect at the bottom of the page. And I'm going to help you with this by drawing a picture. And you might want a picture here. I think we can. I'm going to use the lines. I'm going to model. I'm not going to use the whiteboard. I'm going to use the lines and model for you that they are equivalent. Okay. It says use algebra tiles to determine if 2 parentheses x plus 3 is equivalent to 2x plus 3 and explain your answer. So I'm going to put the picture of 2 parentheses x plus 3 right here. I'm going to put an equal sign and a question mark, and then my answer right here is going to be yes or no. Okay. And I'm going to do this picture right here, 2x plus 3. And this one's going to be easier to draw because it's going to be just 2 x's, and that looks like this. I'm going to put an x there. They put a plus sign up top, but I'm going to put an x. And then 3 singles. 1, 2, 3. So that's easy. 2 x's and 3 singles. Now the question is, does this have the same amount? Well, we'll find out. X plus 3, just in parentheses, looks like this. 1, 2, 3. But this right here says I have 2 of them, so I need to draw another one of those. X, 1, 2, 3. Do I have the same amount? Over here I have 1, 2 x's, and over here I have 2 x's. Over here I have 1, 2, 3, 4, 5, 6. Over here I have 3. Are they equal? The answer is no. They're not equivalent. And it doesn't, I guess it does say explain. I'm not going to explain. I just drew a picture. I'm not going to explain my answer because it says use algebra tiles. And if you have a picture here, then that is your explanation. I'm going to write not equivalent. All right, No is fine, but not equivalent. They're not equivalent. We just proved it using algebra tiles. All right, excellent work. We are done with page 276.